Welcome to JVM Internals Interview Crashcasts. I'm your host, Sheila, and today we're diving into a common interview question for senior backend engineer positions. We'll be exploring the JVM architecture, its components, and how they work together. Joining me today is Victor, an experienced Java developer. Victor, thanks for being here.
Thanks for having me, Sheila. I'm excited to discuss JVM architecture today.
Great, let's jump right in. Victor, here's the interview question. Can you describe the JVM architecture?
Certainly, the Java Virtual Machine, or JVM, is like the engine that runs Java programs. Its architecture consists of several main parts: the class loader subsystem, runtime data areas, execution engine, and native method interface.
That's a great start, Victor. Could you break down each of these components for our listeners?
Of course. Let's start with the class loader subsystem. Think of it as a librarian for Java programs. It's responsible for finding, loading, and preparing Java classes and interfaces for use. It reads the compiled Java files, checks if they're valid, and organizes the information for the program to use.
That's a helpful analogy. Now, could you tell us about the runtime data areas?
Sure, the runtime data areas are like different sections of the JVM's memory. They include the method area, which stores class information, the heap, where objects live, Java stacks, which keep track of method calls, PC registers, which remember where in the program we are, and native method stacks, used for non-Java code.
That's quite comprehensive. For our listeners who might not be familiar, could you explain what native methods are?
Certainly. Native methods are like bridges between Java and other programming languages. They're Java methods that are actually written in languages like C or C++. They're used when Java needs to talk directly to the computer's hardware or operating system, or when we need super fast performance for certain tasks.
Thanks for clarifying that. Now, let's talk about the execution engine. What role does it play in the JVM architecture?
The execution engine is like the brain of the JVM. It's responsible for running the Java code. It can do this in two ways: interpretation, where it reads and executes instructions one by one, or just-in-time compilation, where it translates entire methods into machine code for faster execution.
Interesting. Are there any trade-offs between these two approaches?
Yes, there are. Interpretation is like reading a recipe step by step. It's slower but requires less preparation. JIT compilation is like preparing all your ingredients in advance. It's faster once you start cooking, but takes more time and effort up front. Modern JVMs actually use both, starting with interpretation and then compiling frequently used parts of the code for better performance.
That's a great explanation. Now, you mentioned the native method interface earlier. Could you explain its purpose?
Sure. The native method interface, or JNI, is like a universal translator for the JVM. It allows Java code to communicate with programs and libraries written in other languages. This is crucial for using platform-specific features or when we need the speed of lower-level languages for certain tasks.
Thank you, Victor. Now, let's discuss an important aspect of JVM architecture that we haven't touched on yet: garbage collection. How does it fit into the overall picture?
Garbage collection is like the JVM's cleaning service. It automatically manages memory by identifying and removing objects that are no longer needed by the program. This frees up space for new objects. It primarily works in the heap, where all the objects live.
That's helpful. Are there any potential issues or challenges related to JVM architecture that developers should be aware of?
Absolutely. One common issue is memory leaks, which can happen when objects are unintentionally kept in memory, preventing the garbage collector from cleaning them up. Another challenge is tuning the JVM for best performance, which involves adjusting various settings. Also, developers need to be aware that different JVM implementations might behave slightly differently across platforms.
Those are excellent points, Victor. To wrap up our discussion, could you summarize the key components of JVM architecture and their roles?
Certainly. The JVM architecture has four main parts. 1. The class loader subsystem, which prepares classes for use. 2. Runtime data areas, which manage memory. 3. The execution engine, which runs the code. And 4. The native method interface, which allows interaction with non-Java code. The garbage collector, while not a separate component, plays a crucial role in memory management. Understanding how these parts work together is key for efficient Java development and troubleshooting.
Thank you, Victor, for this comprehensive overview of JVM architecture. This information will be invaluable for our listeners preparing for back-end engineer interviews. That wraps up today's episode of JVM Internals Interview Crashcasts. Thanks for tuning in, and we'll see you next time.